Okay, for this lesson, we are going to take a look at special right triangles, which is section 9.3 from the book. So I wanted to start off with a warm-up of having a right triangle, having a leg of 15 centimeters and a hypotenuse that's 9 square roots of 3 centimeters. And so the question is, how long is the other leg? And we're going to, of course, use our Pythagorean theorem. It's the main thing we use when we have right triangles. Substituting in 15 for A and then 9 square roots of 3 for C, making sure that we're squaring 9 square roots of 3. And if you can see on the side, I worked this out where I had 9 square roots of 3 times itself, and that would give me 81 times 3, because square root of 3 times square root of 3 is 3, which is 243. And then I subtracted 225 from both sides to get b is b squared equals 18, so b equals the square root of 18, which simplifies to 3 square roots of 2. So again, just a reminder, how do we use Pythagorean theorem? How do we work with radicals? Because we're going to be working with them today. So if you were able to take a look at the first part, you would notice that we were given the leg of an isosceles right triangle, which means both of the legs have the same length. And if you use the Pythagorean theorem each time and simplify that radical, you will notice that the length of the hypotenuse is always the square root of 2 times whatever the length of that leg was. And so the conjecture there is, in an isosceles right triangle, if the legs have a length of L, then the hypotenuse has a length of L square roots of 2. So to find the hypotenuse, you always multiply the leg by a factor of square root of 2. Let's take a look at some example problems where this comes in. So the first one, we were given the side of the leg, the length of the leg. So A would then be the hypotenuse, which is just 14 times the square root of 2. Question number 2 is a little bit more challenging because we are given the length of the hypotenuse, and we need to find the length of one of the legs. So from our given information, we know that 12, which is the length of the hypotenuse, is equal to Q, the length of the side, times the square root of 2. Now we could actually divide by the square root of 2, but that is going to give us a denominator with a square root in it. So we need to come up with a way to get around that. So how can we do that? Well, one of the ways is to multiply by the square root of 2 on both sides, because then this is going to make this radical simplify just to 2, because square root of 2 times square root of 2 is just 2. And then this is going to be 2q. And on the other side, we are going to be left with a square root still. This would be 12 square roots of 2. Then we're going to simplify even further to find q by dividing by 2. And therefore, q is equal to, simplifying this, 12 divided by 2 is 6 square roots of 2. So that's how we kind of use the process in reverse to take the hypotenuse and find the leg. Now, actually, the isosceles right triangle conjecture is very easy to prove. So we are going to do that right now.